So this is our first addressing mode, which is a direct addressing mode that you can see here. So what is direct addressing mode? So basically direct addressing mode is the address of the operand always exists within the instruction. The address of the operand always exists with the instruction. What does it mean? Operand, do you know what does it mean? The data to be operated on. The data to be operated on is basically called the operand. Yeah, so basically this is the address of the data, and the address of the data will always be with the instruction, always be with the instruction. So let's take an example. in00, another out 01, another load with this 2-byte instruction. So first instruction, if you look at the first instruction, then you will see there is an instruction. Yeah, there is a op code here, and this is a address. So int 00, that means the data to be read. This, by that instruction, it is meaning that the data to be read from that input port. From which input port? From 00 input port, and stored to be in accumulator. So the data to be read from this 00 input port and will be written into the accumulator. So basically this is a address from where the data to be read, and this is the instruction. This is the instruction. So address of the data will always exist with the instruction. So first one has gone. The second one, the out, that means something you have to output, something you have to output, or something you have to write into the output port. That means the data to be written, the data to be written from the accumulator, to where? To the output port 01, to the output port 01. So that means this is the address from where the data to be written, and this is a instruction. So data, the address of the data always with the instruction. So that's why that indicates the direct addressing mode. The third one, load the data by that instruction. It means that suppose there are a memory location 8000 8001, in that way, in that sequential way. So whatever the data by that instruction, it means that whatever, suppose there is a 72 73, this is all are the data which has been written here. So this data by that instruction, it is meaning that the data will be stored into this memory location to be read and will be stored into the accumulator, to be read and will be stored into the where? Accumulator. Okay, so here is the address from where the data to be read, this is the address from where the data to be written, and this is the address from where the data to be read. So this is the address, this is the instruction. So when the address of the operand or the data always exists with the instruction, we will call it as a direct addressing mode. Okay, so next comes to the our next addressing mode, which is a register addressing mode. What is a register addressing mode? One of the register among this 8 register, among this 7 register, okay, among this 7 register, one of the register can be used as a source of the operand, okay, or the source of the data. Operand is basically the data to be read, the source of the data, and accumulator is implied as a second operator. You know the thing, simple one. Let's take an example example of this. Example of the addressing register addressing mode is move a b. So this is the source register, this is the destination register from where it should be stored. Okay, so this is a move instruction. Let's take another instruction, add c. Add c, this is another instruction. So what does it mean? So add the value of register A with the register C, that means this is a source register and this is a destination register. So you have to take that value, you have to store that value into the register A, and we'll have to add that value into the register A, and we'll have to store the result also into the register A. Source register, destination register. This all are the example of register addressing mode. Okay, let's take another example. I have told you that PCHL. PC, it's a program counter HL register pair. So the content of the program counter will exchange with the content of the register pair, HL register pair. The content of the program counter will exchange with the content of the register pair, which is HL register pair. So this is also a register addressing mode. Okay, so that was the two addressing mode, direct addressing mode and the register addressing mode, and according their example. Our next addressing mode is register indirect addressing mode. So what is register indirect addressing mode? Here you can see the content of specified registers are used to specify the address of the operand. The content of specified registers are used to specify the address of the operand. Let's take an example first. Basically, this is an indirect addressing mode. Here, the address will not directly given with the instruction. In the direct addressing mode, we have seen that the address port or the address of the location was directly given to the instruction, but here the address will not given directly to the instruction. Okay, so let's see one example. Load xb, ldxb. So what does it mean? This means that load accumulator with the content whose address is stored into the BC register pair. So load the accumulator with the content whose address is stored into the BC register pair. Let's see this thing with a diagram. So suppose this is a load LDAXB. So suppose there is a accumulator. This is a microprocessor, and there is a register pair which is B, C, and this is a main memory here. Okay, so this is a main memory here. So let's take, there is an address 008002, and there is the address 00008001 8002. It's a 40. The data will has been stored here 40, 41, 43 in that way. So this instruction means that load the accumulator with the content whose address is stored into the BC register pair. That means BC register pair in we can see here that in BC register pair the address is stored here, which is 8002. That means it will indicate this particular address, and the data will be read from this particular address and will be stored to the accumulator. So this particular instruction means that here you can see the address location is indirectly given into the BC register pair. Yeah, so that's why it is called indirect addressing mode. Okay, let's take another example. Move A. So move A comma M. What does it mean? That means that load the accumulator. Load, this is basically a destination register. This is basically a destination register. So load accumulator with the content of memory whose address load accumulator with the content of memory whose address is stored in HL register pair, whose address is stored in HL register pair. Okay, so this is kind of, that means we will collect the content from the memory, but the memory address is directly not given here. So it is mentioning here the address is stored where? It's stored in HL register pair. So these two are the indirect addressing mode, because the address location is indirectly given into with the instruction. So let's comes to the next, that means LDAXB. It was the first one, and second was move AM. Third one you may say the same thing, move MA. This could be the third one. So our fourth immediate addressing mode. Our fourth addressing mode is immediate addressing mode. What does it mean? I think you all know with that immediate addressing mode. Immediate addressing mode is, that means that the operand or the data, I have told you the operand means the data to be operated, the operand or data is present with the instruction. Okay, so load that immediate data to the destination, which is given in the instruction, example. Let's take an example. Simple. MVI, move immediate A, 32H. That means that this is the operand or data. Operand or data is here. Okay, you need to store, you need to store that thing, you need to load that operand or data into the destination. This is a destination register, into the destination register, which is accumulator, immediately. So this is a kind of immediate addressing mode. It could be here MVI, instead of MVI you can write B32H, it could be C, you can write BCHLD, you can write any register into that location. So this is the immediate addressing mode. If I will take another example, I would say LXI LXI with this address location, with this address location. What does it mean? That means that load the HL register pair, load the HL register pair with this address location, with this address location. So that will happen immediately. Load the HL register pair with this address immediately. Okay, load the accumulator with this content immediately. Okay, so that's why it is called immediate addressing mode. So now we will go to the our next addressing mode, which is the last addressing mode, which is implicit addressing mode. So here you can see our next addressing mode, which is the implicit addressing mode. What is the implicit addressing mode? So in this addressing mode, there will not be any data or operand will exist with the instruction. Okay, the same thing is here written here, which is in this addressing mode, there will no data or operand present in the instruction, but some kind of operation is performed by the instruction. Okay, so operation may perform in a single register also. Okay, let's first take an example and try to see that example. Complement accumulator. This is a implicit kind of addressing mode. Complement accumulator. What does it mean? Suppose if this is an accumulator and 1 byte is stored here, 1 byte. Okay, so we need to complement the data. How can I complement one data? We need to add 1 with this register data. So what will be the answer? What will be the result after complement this data? Plus 1. So 0 1 0 1 1 0 1 1. So this will be the new resultant data. So new resultant data will be what? 1 1 0 1 1 0 1 0. So this is the new accumulator value. So this is a complement accumulator. Okay, that means this was a kind of implicit addressing mode. So there was no any kind of data or operand present there. Okay, only the instruction was there, and this instruction was defining that this needs to, the accumulator data needs to complement. Okay, so that was one example. So let's take another example, which is RAL. That means rotate accumulator left throw carry. Rotate accumulator left throw carry. Let's take another example. There is also a 8-bit data available in accumulator. And there is one carry flag CY. And here is this is 0, this is 1, this is 0, this is 1 1 0 1 1 0. So that means that rotate accumulator left throw carry. So in that instruction we will enter this kind of instruction. That means data start to rotate through the carry in 1 bit. data start to rotate 1 byte through the carry, so what will be the new one? New one will be, so new result value will be this was a carry cy. So now data will shift 1 bit, so 0 will be here, 1 will be, 0 will be here, 1 will be here, in that way 1 double 1 0 1 1 0, this 0 will come here, and this one will store in that carry flag. So that will be the new result. Data has rotated left through the carry. So this instruction was, if you look at that instruction, then you will see here this was a one instruction, no data or operand was attached to this instruction. Okay, so this was basically our implicit addressing mode. So now that means that by this addressing mode we have completed all the 5 addressing mode.